Yes, so our next speaker is Adele. So Adele is currently a high school teacher in science and mathematics and is completing her PhD in marine biotechnology with a green chemistry focus. Her project is extracting South Australian brown algae polyphenols with antioxidant activity for anti-aging skin health products. Her knowledge stems from bioprocessing of brown algae, analysis of compounds, and dermal delivery systems for skincare. She is an advocate for green and sustainable skin health products and is currently completing a diploma in cosmetic formulation to move towards her goal of commercialization. Her passion also leads into the education space with a driven nature to promote green chemistry and be a leader of change in the Australian setting.
Cool. Thank you, Sarah, for that. Yeah, thanks everyone. Julian, your presentation was amazing. I loved all of those projects, so that's really cool. I'll just share my screen. Hopefully that's going to work. All right. Can everyone see that one? Perfect. All right. So yeah, so my talk is probably not as detailed as what Julian's is, but we're looking at the efficacy of delivering like a green chemistry outreach to middle years. So our middle years go from year 6 to 9. So we've roughly got age groups of between like 11 to 14, 15 years old. So we have a range of different authors around this paper. It hasn't quite been published yet. But this is the team that we're working with from Flinders. And we've had an amazing opportunity through what's called the ARC Green Chemistry and Manufacturing, which is like like an industry-based funding group with a whole range of PhDs and postdocs that were able to, deliver this sort of community project, which is really awesome. Such an awesome opportunity for, I think, for the Australian context. So the current status of green chemistry education, particularly in Australia, we only have like chemistry outreach only. There's only a focus on engagement, and it's strongly actually uptaken by private schools with a lot of opportunities. And something that we're sort of noticing on our end is that we're getting a lot of disengagement from so many different students, particularly in a low socioeconomic status, because they just don't see that connection. And so what we really wanted to do is try and really progress and come up with something really novel that we can do in this context. So the current situation that we've got, obviously we've got the 12 principles of green chemistry, we've got Beyond Benign, which is fantastic. In terms of the Australian context, we started green chemistry education sort of around the 1999 era, where actually my supervisor, Professor Colin Ruston, he was originally at Monash University in Victoria, and so he then started this program. It sort of plateaued for a little bit, but moving forward in 2020, that's when we came up with the Training Centre for Green Chemistry and Manufacturing. So that's where we've got our PhDs and postdocs and things like that. The only aspect that green chemistry education fits into now with the Australian curriculum is version 9. And version 9 has only just sort of been rolled out, and there's maybe a sentence of green chemistry at year 9 level. So it's not really being promoted. I think we're sort of a little bit behind the 8 ball at the moment. So we really wanted to sort of drive this as well. And we've noticed a number of gaps in this education space. So we need really outreach activities that have a green chemistry focus. If we can put an impact on that, then hopefully, the policymakers and things like that will actually transition and put that into programs and things like that in the education system in Australia. Our outreach activities need to really be connected to the curriculum. We've got a whole range of codes that we actually connect to, but if we're not doing that, we're not going to have teachers uptake what we're doing, the programs and things like that. So it's going to be really hard for them. They're already so overloaded anyway. It's really going to be hard for those to integrate into, take on these new aspects and concepts and things like that. We also teach to a range of different teaching models. And so there's no particular teaching model when we sort of roll out these new concepts. And so we were looking at the 5E model. I'm not sure if anyone's actually familiar with that one, but we were looking at engage, explore, explain, elaborate, and evaluate. So that might ring a bell. So basically we were designing this outreach with that concept and that teaching model. So then that way when teachers were going to take this up, then they could actually transfer it across. So the survey that we developed for this outreach was fairly basic. We had sort of a before the session and after session range of questions, and then we're able to graph this and tabulate most of these answers as well, which is really exciting. So basically the sample size of going through this was over a 2-year sort of study, and we had outreach opportunities every month. And we also had like a 3-day conference event, workshop conference event where we would have, 200 odd students come through. One of the limitations that we had was the fact that we were only delivering this to Year 9 girls. So we had an amazing opportunity, what's called the Year 9 STEM Enrichment Girls Program, and we were doing that at Flinders University. So that was run by Professor Maria Parapilli, and she had a range of funding opportunities to sort of roll that out and have this inclusive education aspect. So so that's sort of where our limitation lies. Our original plan was to go into schools, and we're still going to run this and hopefully go into schools as well, where we can actually open up the gender as well, hopefully through this. So our first experiment that we've got, we had biodegradable water bottles. Now, this is a very, very simple experiment. Most chemists probably know this one, where you actually get a drop of alginate and you pop it into calcium chloride. And what it does is create sort of little beads, and you can actually explain the fact that you've got a polymer coating and then you've got the milk or the juice or the water on the inside there. And kids love it. Like, it's so engaging, which is super fantastic. So one of the questions that we had was this was the prior question. So I find chemistry, and then I find chemistry relevant to real life. So you can already see that, these students that are coming on board before they even start the experiment, they're actually fairly engaged, which is something that probably I wasn't aware of. You sort of get these students from low socioeconomic status that are like, I don't really understand this, I don't really pay attention to it, but you can actually see they have a level of interest already in the program, and they can actually see some sort of connection to real life, which is fantastic. You can sort of see that shift. So the red is afterwards, and you can see that shift across into, very likely or fascinating, things like that. So these are the short answer questions. And you've got the questions of, did you enjoy today's experiment? Why or why not? And one thing that you learnt. So it's really exciting here that our purpose was to deliver something that was fun and engaging. And you can quite clearly see that, yes, it was fun and engaging in that first graph of about, 27%. Which was fantastic to see. And the one thing that you learnt is that you've got this concept that seaweed can actually potentially replace plastic. And so then they're now making this connection between something that's a natural resource to green chemistry as well. And part of this is we're looking at, you deliver the green chemistry principle, something they've never heard of, and they're really starting to make these connections. This is probably my most exciting bit of data that we've got, and it's really hard sometimes to see the progress of students and their level of thinking. So what we've done is, one of the questions that we had was, do you have any questions left over? So we separated these into different levels, so A, B, C, and D. So A was like the high level critical thinking, and it was around industry based and future directions, whereas the D level questions were sort of, I'm not really quite sure, whereas the C level questions were direct experiment type questions, where they're not sort of like actively thinking about the future. And things like that. So you can actually see that their level of thinking is quite high. They're going from, scientific based questions to industry based questions. And what's so exciting is that they actually were asking questions that researchers are already still trying to find out. So, you've got 13, 14-year-olds already asking these questions. And I think, for a promising future, I think that's really cool. So post-experiment survey questions. So we were looking at whether or not they were going to study chemistry in the future, particularly green chemistry. Still, a lot of students are not quite sure about this, but if you think back to when you're in school, you probably weren't quite sure about what you were going to do. But the main purpose of this was to also allow them to have the concepts and the knowledge to bring this back into the home, and communicate with their parents and actually spread the word. So although they weren't quite sure how they were going to use chemistry in the home, they were still able to articulate, hey, I want to tell my mum, or I want to tell my dad about this, or I want to tell my brother and family and things like that, which I think is a great idea for that as well. I'll just skip through that one. So the second one that we had, so based on all of the information they had around green chemistry principles, we then decided to develop what's called a sustainable soap formulation. And so this was looking at the reuse and recycle of ingredients in sustainable soap. And so basically they were able to take a hard soap, break it down or melt it, break it down, add glycerol and food coloring and alginate, and then able to add sort of like the oils from the orange peel and lemon peel and things like that. And we had bits of lavender that were able to add into there. And so it's super exciting. So you can already see there's some examples of soap that were there. They were able to take this away as well, which was awesome. So again, same sort of questions. Again, fun and engaging. They were also able to learn about how soaps work, which was a fantastic thing to take away because they don't typically learn this until year 11 or year 12. So when they're, 16, 17 years old. So they're already starting to make these connections to the real world. Again, my most favorite slide, you can actually see that they're high level critical thinking. So they were only able to do this if they've done the water bottle prac, because they needed that background information to be able to progress, particularly with the alginate from seaweed and things like that. So the higher level critical thinking questions actually increased, and this was at 38%. So again, if we're thinking industry based and future directions, this takes sometimes a really long time for these to develop this skill, but you've got 38% of these students out of 500 girls that are already thinking like this, which is honestly amazing. So you can see this shift in sort of studying chemistry in the future and bringing chemistry in the home. Obviously, they're developing soap. This is probably a little bit more applicable to be able to, and achievable to be able to bring back into the home. So that was really exciting. You can sort of see that shift in those graphs to the right there. So this was looking at two different graphs. So this is looking at, have you heard about green chemistry before? And this was between the two experiments. So the one on the left was the biodegradable water bottles, and the one on the right was formulating sustainable soap. So like I said before, they had to have completed the biodegradable water bottle one before doing the sustainable soap formulation. And you can actually see the complete shift in, yes, I've heard about green chemistry before and how they can potentially use it. So I think reaching out, this is really working to some degree. And I think it's fantastic that we're really trying to reach this audience. This is also another really exciting display of data. So this was, one of the questions was, how can you connect green chemistry principles, and what can you recall from the green chemistry principles after the experiment? How can you connect them, basically? And so you've got all of those green chemistry principles. The bigger the square, the more responses there are. Other categories were sustainable, being environmentally friendly, and just simply the 12 principles of green chemistry. So you can already see that they're recalling this information. Waste prevention was probably a big one between the two, but again, they're already sort of connecting with this, and they're really starting to think about how the green chemistry principles fit into this. So, really hoping that in the future they're starting to look at this in terms of their career pathways and whatnot. So just a few key takeaways. So green chemistry is a rapidly emerging area of science. It's been recognised by the education sector. The whole aim of this is to really try and shift education. I'm really hoping South Australia is going to be a driver for this. Obviously, me being teaching in a school, I'm really hoping to take this away, redevelop it. And for our year 11 and 12s, which have a stricter curriculum, hoping to maybe integrate this, which was an opportunity that I came across yesterday, which was actually very exciting. Obviously, we've got highly adaptable resources that we can promote in schools. We've got fostering higher order thinking questions, which again is my favourite part of this. And we've got a significant uptake by lower socioeconomic students. They're finding, relation to this, which is awesome. So yeah, I think it's really exciting. We've now reached, a total of, 500 students. We've got a massive day of this tomorrow. which is actually why I'm going away a little bit earlier. So we've got another 100 students that we're going to target tomorrow as well, doing these experiments, which is fantastic. We actually have the minister and things like that coming to have a look. So we're really starting to make a very strong impact through this. Just want to acknowledge the STEM Enrichment Academy, a huge opportunity from Maria Parapilli, a very big collaboration between Monash and Flinders University in particular. And just want to say a big thanks to the outreach team at Flinders, in particular Safira and Tessa from Monash as well, because they have been running a whole heap of stuff while I've been teaching and been a little bit MIA recently. So I also want to say a huge thanks to the ARC Green Chemistry and Manufacturing committee for also putting this together and providing opportunities and being the best team possible. So thanks.